So this demo shows how to test Camel K integrations and Camelets locally and in Kubernetes using the test framework YAKS. So let's start with a simple Camel K integration. This is using the timer component to periodically send messages to an HTTP service. This is the greeting service, and the response should be logged to the output. So I can test this Camel K integration using YAKS. Typically, you write a so-called feature file, and in that feature file, I'm able to actually create this greeting service. So this will create the HTTP service so that the Camel K integration is able to send the requests to this service. Then I'm able to load the application properties file for the integration, and I'm able to load the Camel K integration itself. So this will then create the integration, and the Camel K operator will just reconcile this integration and start it as a pod as usual. And then I can wait for the integration to be in a state running. And once this is running, then the timer should periodically send requests to this greeting service. So I am able to actually receive such a request. I can expect the request body, and this request body comes here from this set body. It's using a message property, which is in the application properties. So this YAKS rocks should also be in the request that is sent to the greeting service. And I can receive this request, and I can actually send a response back. I'm sending this thank you back to the integration. And once this is done, then the Camel K integration should actually log the response, and we should have this in the output, in the Camel K integration output, saying thank you. So this is a typically YAKS test that I can run using the YAKS CLI. So let's remove this, and let's on this. I have Minikube running on my machine. So this creates the test on the Minikube and will run the test in the cluster as part of the Kubernetes environment, creates the Kubernetes service, greeting service, and the Camel K integration. And then if all goes well, the integration should be able to send the request to the greeting service and handle the response. So it takes a while for the Camel K integration to start up. And once this is done, so now the Camel K integration actually received the response, and everything is happy. This was the test running in Kubernetes. This is good for like end-to-end testing because everything is involved in here. Like the Camel K operator is reconciling the integration. It starts the integration. The integration talks to a Kubernetes service and receives the response. On the other hand, this is a quite big turnaround because if you're in a development mode and you develop your Camel K integrations, this is with Minikube and everything set up before. This is a quite big turnaround and round trip. So what I want to show you now is that you can run the same test that we just run in Kubernetes. You can also run this on your local machine. You just add this local to the YAKS command, and then the test will not be run in Kubernetes, but it will be run on your local machine. For this to happen, we, of course, need to adjust the HTTP request URL here, because the greeting service won't be available in that, and we want to have this as a local host and actually give the port. And this is something to keep in mind, because running in Kubernetes is a bit different than running locally. But yeah, let's just run this test local. This is now using Camel JBang integration. So the integration will be run with Camel JBang, and this is extremely gaining some speed here. Yeah, and the same test that we have seen before running in Kubernetes is now a little bit faster, and you will have the opportunity to actually have a better development cycle with your integration, changing the integration, changing the test, and so on. So one thing that you can do, instead of changing this local host and greeting service all over the place, you can use a so-called function in YAKS, which says resolve URL, and you give the name of the service. So as YAKS is creating the service and knows which mode we are actually running, in local mode or in Kubernetes mode, YAKS can also resolve this URL for you. So depending on where we run the test now, it is using the local host endpoint, or it uses the greeting service endpoint with the namespace when running in Kubernetes or in OpenShift. And another thing that you can do is to actually go here and fail a test failing. So we want to receive a post message, but let's send a put message for this. So we're running locally, and this should be failing because the test just expects a different request method. And yeah, so as expected, we have here this expected post, but it was put. So let's quickly maybe fix the test in here to expect a put message. And yeah, this shows that the development cycle is quite faster with this, instead of running everything in Minikube, because also the integration kits maybe are rebuilt, and this takes a lot of time. So running this locally with Camel JBang in integration is really, really fast, and should make you happy. So look into another example, which is also using test containers. So let me see here. In this example, we have a Camelot binding, and this Camelot binding uses an AWS S3 source. And every time there's a file on this S3 bucket, then it does some JSON transformation. It replaces a field in the JSON structure, and then it, as a Camelot sync, it also sends out to an HTTP endpoint. Here I'm already using this resolve URL function, and we are able to actually run this Camelot binding too on a local basis and on Kubernetes. Let's have a quick look into the test case. So yeah, same, we create this Kubernetes service. This time it is called message service. And then we create an AWS S3 test container. So test containers is a great library for different third-party libraries and third-party services to quickly start and stop these for testing. And these two steps in here will actually start a test container, the local stack test container. And once this is up, then we can use the AWS S3 service as usual. And then, of course, for some other things in between, we start the Camelot binding. We wait for it to be in a state running. And then we send an S3 file to the AWS bucket. We use Camel for this step. And then the Camelot binding should receive the S3 file and should do its transformation and actually send out this HTTP request to the message service. So on both sides, we have third-party libraries. On the one side, we have an AWS S3 source, and on the other side, we have an HTTP sync. And in this test, we are simulating both sides, and in between, we have this Camelot binding. And as usual, we are able to receive this request. It's a post request, and we send a response back. And then we clean up some resources, cleaning the Camelot binding, the service, and also stopping the test container. So let's go here and let's run this. It's in test AWS S3 to HTTP. Feature and run this locally. Now JBang is detecting and resolving all the dependencies that we have. It actually starts now a test container on my local host in Docker. And once this test container is running, then we are able to actually use the AWS S3 source with the Camelot binding. It starts a Camelot binding, and we have a green test. And it's pretty fast because of test containers is quite cool library to test all these third-party services that we have. So that's it for this little demo. Of course, you can run the same test also in Kubernetes. It takes a little bit more time because you run the Camel K integration or the Camelot binding. You build the integration kits, and you start also the AWS S3 test containers in Kubernetes. This is also something that YAKS is able to do, to run the same infrastructure also on Kubernetes. So it's both worlds combined, which is pretty cool, what I wanted to show you. Thanks for watching.